Hello, my name is Magda. I'm a Scala developer at Software Mill. Before starting working with Scala, I used to be a Java developer. And it's during my first years in Scala that I met something, this new testing library, which I'd like to talk to you about. And at first, I thought, okay, it's just another testing, it's another library in Scala, so I will do the same things, but I will do them the Scala way. But then, when I learned how it works, it turned out, I thought, wow, so now that's pretty innovative, that's pretty powerful. And really, why hasn't anyone told me about it before? You can easily do that outside of the Scala world, outside of functional languages. So today I would like to show you how to do property-based testing in Java. And the reason why I thought this property-based testing is so powerful is that it actually does some of the work for you. So your role is to define some rules, and the role of the library is to verify for you if those rules still hold, or maybe if there are any edge cases. So today I will show you what property-based testing is about. I will show you example code. I will show you how to get started in that in Java using this kind of library, and how to write your properties. And even though I may sound like a sales-based person right now, I will also show you where the fine print is and what are the challenges and when property-based testing is maybe not such a good fit. So let's start. Let's start from an example. Let's imagine we have a sample business domain where our business logic and our business function needs to calculate a discount. It takes an instance of a customer and the date of today, and it returns a big decimal. And the discount for the customer is proportional to how many years they are with us. So if they are less than 1 year, they don't get any discount. If they are between 1 and 2 years, they get 10% discount. And if they are with us more than 2 years, they get 20% discount. So as it's a big decimal, it will be 0.2. And there's also a special case, so that it's not so simple. If the customer has their birthday today, they get 30% discount. This is our customer class. It has a name and the date when they joined and their date of birth. Maybe some other fields, but we don't need them right now. So how would we, let's assume we have our discount method already written and we want to test it. How would we go about that in a traditional way of testing? We will call traditional testing example-based testing as opposed to property-based testing. So in example-based testing, what I would do is I would prepare tests like that. So at first, a test case to calculate that 10% discount is properly applied. So we've got a customer, we've got a sample today date, we know when the customer was born, it's not their birthday today. We invoke our method and we verify that the discount is 10%. We would also verify that for 20% discount, the same is true. So everything else is the same, but the customer has joined 2 years ago. And we verify that the discount is 20%. Is it enough? Of course not. So we want to add some more cases. Let's add the birthday case. So we we prepare a customer who was born 30 years ago, and it's their birthday today. We verify that the discount is 30%. So now I would say, okay, it's pretty well tested, but let's think about edge cases. So I would add those two test cases as well. First is to verify that if no discount should be applied, then our method returns 0. So if our customer joined just today, they get no discount. Okay, that's fine. And maybe a case for to make sure that the discount is not too big, even if the customer is even 3 or more years longer with us. So we prepare a test case when they're 3 years with us, and we verify that discount is still 20%. And if I wrote such 5 test cases in traditional testing, I would say, okay, it's well tested, the edge cases, the happy path, so I'm ready to commit, push, and let's move on to a new feature. And how would that be different with property-based testing? Now, if we're talking about property-based testing, it would mean that the property is somehow at the center of it all. So let's talk about what is it. So in property-based testing, property is some kind of a property or a feature or an invariant of the code, which holds always true. So no matter what input you give to your method, there is some property which holds true to the output. And in property-based testing, your role is to define such an invariant and write it as code. And the role of the library is to generate sample data, random data, run your test a lot of times, and verify that your property is still applied. If it's not, it means you have a bug. So how would it look like in the code? Let's go back to our example business method. And what could be our properties there? Well, one of the property could be that no matter what customer and today's date you give to the method, the discount is never less than 0. It's never less than 0%, or in our big decimal, less than 0. Another property could be that no matter the input data, it's never more than 30%. And as you notice, such properties, they don't always fully define your method. Because in example-based testing, you have a concrete input and a concrete output, and you know that this is correct. And here, the properties, sometimes they are not so concrete. They just put your method within some kind of sane boundaries. And it's good. And that's what they're for, because you want to define those sane boundaries and ensure that your method never acts crazy, that it always acts within these boundaries. But another example of such property could be that the discount is always proportional to the number of years that the customer has been with us, if it's not their birthday today. So the longer the customer is with us, the bigger the birthday, the bigger the discount. And for the birthday, we could say that a discount for a customer who has their birthday today is always bigger than the discount for a customer who doesn't have their birthday today. And such things we can write as properties. So let's show the code for one of those properties. But if we want to look at the code, let's talk about libraries. In property-based testing, library and the choice of the library and the quality of the library is very, very important. So when did it all start? Not in the 70s. It might be surprising because a lot of things in computer science started in the 70s. But the first property-based testing library was written in 1999 in Haskell and Erlang. And since then, a lot of implementation were created in many different languages. However, here the libraries, they are not all created equal. So for example, between them, the Scala library is very, very good. And some of those libraries between them are, let's say, basic. And here in property-based testing, the libraries, as I said, are very important. And during this presentation, I will show you the features of property-based testing, which the libraries can do very well for you. They can be very helpful and very, very smart, or another library can do it in a very basic way. So where is Java? among these libraries. In Java, we have about, I think, 10 or 15 libraries, different libraries for property-based testing, but not all of them I would recommend to you. Some of them are old, some of them are abandoned, some of them are very basic and don't do a lot of work for you. But I have prepared here 3, which are quite good. They are all modern, they are well maintained, they are dynamic, and they have all the features that you would need to start with and to write good property-based tests. What they differ between themselves is that whether you want to use them with which framework, JUnit 4, JUnit 5, or maybe TestNG. And additionally, this Quick Theories has a special DSL, so you'd have to look at it to see if you like it or not. And for the purposes of this presentation, I have selected jQuick, and all of the subsequent examples will be in jQuick. However, all that I talk about can be done easily with both of the other 2 libraries, and most of the libraries in other languages as well. So here is the example that we were waiting for. I have chosen the property that the discount is never larger than 30%. So it looks like that, a test case, which here inside invokes our business method, and it checks that the discount is not more than 30%. What happens here? We have a property annotation which tells jQuick to discover this test case as property test case, and we've got input arguments or parameters. We've got this for all annotation, and this is the annotation where all the magic happens. Because what happens here is we tell jQuick, please jQuick give me a sample customer and a sample date of today and verify this property for me. So what jQuick does is it creates 1,000 of such sets of data, and it runs our test for each of those 1,000 sample data. And I said sample, but it's not completely random what the library does. It's something that you would call, I don't know, bad random or vicious random, because what the library does is it wants to break your test. So it will create tricky data which maybe you haven't thought of, which can break your implementation. So for example, it can be 0, it can be negative numbers, it can be special characters, things that we don't often think about, or we don't think about that enough. So when jQuick or another library calls our tests 1,000 times, what happens is if one of them fails, jQuick will return such output for us. It's a lot of stuff, so let's start from the end. At the end is the sample which jQuick found that our test fails for. So as you see, it's pretty random, but it could be even more random, really. Just some string and some date. However, jQuick doesn't stop here. Here we have this very interesting thing, because we have a simplified case. So what jQuick does is it tries to generate simpler and simpler data for which our test still fails. And it's very, very helpful. It's called shrinking, and it's one of the things the library can be better or not so good at. If they have a good shrinking heuristic or algorithm, it means that the shrink the data, it's very helpful because you can instantly see or very quickly see what your problem really is about. And here, looking at this example, do you already know what the problem in my implementation was? Yes, it's the 29th of February. So it's leap year, and my implementation didn't take it into account. And actually, my code threw an exception there, so the test failed. So it's something which I wouldn't have discovered in my simple 5 example-based test that I have showed before. And that's where property-based testing really shines. This is really what it is for. It's to find edge cases which you haven't thought of, because when you implement your code, you are so biased. You have a couple of example data that you think about that you don't even think of outside the box. And the library is unbiased. It will throw a random or vicious random data at you to verify whether it's still okay. So let's assume we already know where the problem is and we fix our code. What happens now? In traditional testing, I would just run the test again and see if it's okay now. But here it's random data. So what can happen? Is the test green because I have fixed the problem, or is the test green because I've got some different kind of random data and this edge case isn't found? Fortunately, jQuick is smart about it. What it does is it saves the seed of the data. If we talk about randomness or pseudo-randomness, there's always some seed underneath it from where the randomness starts. So what it does is that after failure, when you run the test again, it will use the previous seed. So you will have the same set of data generated. So you can be sure that if the test is green after failure, it means you have fixed your code. Now let's talk about generators. In jQuick, in property-based testing, generators are really important. This is the thing that provides your data for you. So it has to be, your role is to make it as close to your production data as possible. So you want to use the generators which will provide you data which are correct from your domain point of view. Because you don't want, if your test fails, you want to make sure that it's because it has spotted a bug and not because it has generated some data which you don't really care about because they are not correct in your domain, so your code doesn't have to provide for it. In every library, you will have generators for basic types out of the box. So for example, in jQuick, you will have them for strings, and you can make them more specific, for example, to specify how long the strings should be, or what kind of characters they should have, maybe alpha chars and numeric chars, and also a couple of special chars and white spaces. If you don't provide an annotation, you will get white spaces, non-printable characters, kanji characters, Polish special characters, and so on. So not only simple characters. For all basic numbers, integers, big decimals, doubles, and so on, you will have generators out of the box in every library, and jQuick as well, and you can specify ranges and so on. You can also have collections, and what's nice is you can further specify both the size of the collection and the type of the elements that are inside. You can also work with optionals. So in this case, I think 5% of the data would be with an empty optional. And here, if you work with nulls in your domain, in 5% of the time you will get nulls to make sure that your code behaves correctly also for such cases. What you can do further is you can make them even more specific. For example, let's say we want a test case which works on a string and an int, but not just any string. We can define even more how the strings should look. So we can provide argument to this for all annotation, which will specify the name of the method, or an argument to the provide here. And using the static methods on arbitraries class, you can further specify what kind of strings or data it should be. In the language of jQuick, arbitraries is what I call the generator. So here this method returns a generator or an arbitrary of string types. So you can say you want strings with such character range, but not Q, and of specify length. And also for numbers, you can use the static methods here. But what happens if you don't have, if your data is more complex? For example, as our customer type. You can combine generators, and that's something I will show here. Here I need a generator for the customer type, and we know that the customer had a name and 2 dates. So I'm using this for all annotation and specifying that I will create the generator here. And here I will need at first 3 generators of the string. So here this is created as we have seen before by static methods. Then we need a generator of local date, but jQuick doesn't have an out-of-the-box support for dates, and it can happen for your library that your library won't have a generator for something out of the box. So what do we do here? What we do is here in this helper method is you start with an existing generator, like here you have a generator of longs, and you base your generator on it. So what happens here is this method will take the minimum and maximum date, and here we will say that the minimum for the date when the customer could join is when our business started, and the maximum date is now. At first we need to calculate the range between those minimum and maximum dates, and out of this range we create a generator which will generate random data from between the minimum date to the maximum date, or actually from 0 to this number of days between. And what we do is we map it. So we provide an argument to the map method saying that for this found or generated long number, add it to the minimum date. And this way we get an arbitrary of local dates where the smaller local date would be the beginning of the range, and the maximum would be the maximum of the range. And such helper method we can use also for the date of birth, just specifying different start and end dates. And what do we do once we have those 3 arbitraries? We combine them. Using the static method combinators combine, we provide the 3 generators, and we tell jQuick how to join them. So here the constructor of the customer class takes a string, the join date, and the date of birth. But you could provide another method and say that you want it some other way. So that's what you can do, and you can be very special and very sophisticated about your generators, and that's a good thing, generally. Generally, you want to provide generators for your domain classes, for the most important classes in your code base, in your project, and run a lot of property-based tests on them. And if you don't want to specify the method every time, there is some mechanism in jQuick which you have to just implement some interface to tell jQuick that anytime you find this customer type, use this specific generator which I defined to you in this case class. You can look it up in jQuick documentation when you look for default generators. It's a very good thing to do, to have such default generators for your most important classes in your project. And when those techniques are not enough, there are also 2 more techniques that you can use to make the generators better and more yours. The first one is assumptions. And they come in handy, for example, if you need to specify relationship between your types. So for example, here we want to verify that the discount should be proportional to membership years. We generate 2 customers, but we only want to work on the customers when they don't have a birthday. Their birthday is not today. And we also want that to assume that one of them is joined before another one. So one is older and another is newer. That's something that can be achieved that way. And then we calculate discounts for both of them, and we make sure they are proportional, correct. For assumptions, you need to make sure that they are not too difficult, because if JQuick really struggles to find such data, where that assumption is true, it will either take a lot of time or generate, or it will say, I cannot work with that, I just give up. So you cannot make it too complicated. And another technique which might be handy are frequencies. So here we might want to say that some kind of data in the generator should occur more than some of the other, to more closely resemble our business cases. So for example, here where we calculate the membership years for such domain, we want to say that these values come with such frequency. So in 30% of the time, the customer is 0 years with us, and in 60% of the cases, they are 1 year with us, and in 7%, they're 2 years, free. Those numbers don't have to sum up to 100, but if they do, it's just easier for you. And it's good. It's a good technique if you know that you have some problematic values in your domain, and that you want to test some values more intensively than others. Okay, so let's talk about challenges. Because you know you don't ever have problems, you just have challenges to overcome. Why don't we already use property-based testing? I think they are great, but why doesn't all of the world already use them? And should we just come to work tomorrow and throw away all our example-based tests and replace them with property-based testing? Well, it's not all shiny like that. There are a couple of challenges where you have to be careful. First of all, in traditional testing, what I like to do in example-based tests is I get to know my domain. I write some simple implementation of the method, maybe using TDD. So maybe I write a test, then I write the implementation. The test fails, I write a better implementation, another test, and so on. And during this process, I get to know my domain better. And then when I think I understand it quite well, I think about the edge cases and what will happen to my code if I throw strange data at it. Here in property-based testing, you cannot really do it, because the first thing you need to define when writing your test is what is the correct data. And do we accept zeros? Do we accept kanji letters? What is the highest number a person can earn a year? What is the longest surname you can have? All those questions you have to write at the start to write your generators. So sometimes it means that before you write your first line of test, you have to go back to your product owner and ask them the difficult questions. So it's not so easy. You have to break your habit. The second challenge is the most difficult challenge in property-based testing. It's not always so easy to come up with properties which would test something, which would give you some value. It will test something that is important to you, but you cannot repeat the implementation, because if you just write the same in the test as in the production code, it doesn't give any value. And here I have shown you a couple of examples of the properties. but when you go back to your project tomorrow and you want to start with property-based testing, you may end up staring at a blank page or blank editor window. To come up with a good property, it's not trivial, and it's something that you will get better at with time. But fortunately, there are some lists of patterns which you can consult to as an inspiration where you're thinking of properties. And here I will show you 4 such patterns, and then later you will have a link to a long list of patterns to consult. The first pattern is Oracle, but not Oracle as in company name, but Oracle as an entity who knows the right answer. So if the method you are writing is for some functionality or for some logic which already exists somewhere, and you can compare them, then you're a really lucky person. Maybe you are writing an ordering function, some specific, very fast ordering function for some kind of data. But you can also use a standard library function just to call it in your test and to verify that your numbers are sorted. If you can, that's great. And that's what it's all about. In my experience, my Oracle once was a spreadsheet. I worked with financial data, and the spreadsheet had macros. And if you input the right numbers in some of the cells, the macros worked, and you had the correct answers in some of the other cells. And my task was to provide the same calculations and present them in a different way, faster way, not using the spreadsheet, but they had to be the same. So what my test did is it used this file with macros, it put the randomly generated data into it, and it verified that my functionality is correct according to the spreadsheet. And this example with the spreadsheet is special because you have to be careful with time. Here, if your test, for example, creates files or works with files just to test something, it can be slow. And remember that jQuick runs your test 1,000 times. So here it might be a time to tell jQuick in an annotation, this method, let's only call 100 times, maybe not 100. Otherwise, you wouldn't want to put such a test in your unit test, maybe in the integration suite. But generally, I used to put my property-based testing in the unit suite, and it was the time was acceptable, and it gave me some kind of confidence about my code. Another pattern is alternate wording. So what you do is you describe the problem that you are solving in your business code in different words, and that is an inspiration for a property. So, for example, again, if we were writing an algorithm to sort a list, what can you say? It means that the end list is sorted. Well, that would be repeating the production code. So let's say the end result, if you take a number, it's bigger or equal to the number before it. Now that's a very good alternate wording, and it already gives us a property. We can check the pairs and see if they are ordered this way. And this is a very good property. If you can define your problem in different words and check the properties using that, it's very good. And last of the patterns that I wanted to show you are invariants. So, for example, in case of ordering a list, the end result will have the same number of elements as the input. For example, what doesn't change is that if a number is in the end result, it always had to exist in the input as well. It's not out of the blue, and so on. So something that doesn't change after running your method. It's very good, and it doesn't it doesn't specify in 100% what your code does, but as I said at the beginning, it keeps your code in a reasonable boundary and makes sure nothing blows out as a result. Oh, and there's also one last pattern, it's symmetry. So for example, if you have a code for serialization and some code for deserialization, you can run them together and verify that at the end you have the same that you had at the beginning. Another examples could be writing to a database and reading back from the database, or maybe if you reverse a list, then when you reverse it again, you come back to point 0, to what you had at the beginning. What's one of another challenge is non-determinism. So imagine we have a code, we have a piece of code, we've got tests, property-based tests, they are green, you commit, push, and on Jenkins they fail. And maybe even not instantly, maybe they fail in a week, maybe they fail in a month. That's what can happen with random data. So what do you do about it? You accept it. You accept it as something which is good actually, because it's the library which found your edge case for you and not the client, which would otherwise spot it by throwing really strange input data at your algorithm. So that's something you have to live with. It's some kind of eventual edge case finding. And another case of non-determinism is, imagine you have a bug, you fix the bug, and then it's fixed, it's green, but then your code evolves, and 1 year later somebody introduces this bug again. But you have random data, so you won't spot it instantly that your code was broken, and you don't even know when the code was broken. So you cannot spot the concrete commit. What do you about that? Well, you do not accept that. What you do is, when you find a bug, you fix a bug, you provide a traditional example-based test. You put it in your code base, you make sure it's run as a unit test every time you test your code. So that's one of the reasons you cannot just throw away your example-based tests right away. They have to coexist. You have to have some of example-based tests and some of the property-based tests. And the last challenge is documenting. Our brains likes to think with concrete examples. So when I find a new piece of code, I often go to the testing file and read the first happy path green scenario. And it means a lot to me at that point. At that point, I don't need some invariants, some assumptions, some weird alternate wording of my code. And for that, for documenting, property-based tests are not so good. So I think it's still good for example-based tests to live to do this. So as we are going towards the end of the presentation, and I have told you that the property-based tests are great, but at the same time they are not so great. So I would like to leave you with 2 strategies that you can start to apply if you want to try out property-based testing. The first one is to start traditionally. When you write a new piece of code, write example-based tests, and only when you know your domain really, really good and you think you have fixed all the bugs, start with property tests. And maybe they will find for you more edge cases. Maybe you will have to come back to the business people, talk to them about the edge cases, fix your code, fix the way you think about your code. Maybe you didn't discuss something through, maybe you understood something in a different way, and so on. So that can be a long journey. So that's a good way to start. And another strategy is to provide property-based testing only for key components. You know, those property-based testing, they take quite a lot of time to write. They are sometimes hard to think of. And given this, you don't have to have properties for some trivial parts of your system. Sometimes you may want to save them for the key components. So the ones that, for example, are very complicated, do some weird things, and nobody really knows about, you want to have them tested correctly. Or for the components which are critical, so that if they don't work, somebody will lose money. Maybe your client, maybe the customers of your client, they're critical to your business, and you want to have them very, very well tested. Provide property-based tests for that. To sum up, it's something that doesn't come at no cost. You will have to think harder. Sometimes you will have to consult your colleagues. You will have to consult this prepared list of inspiration patterns. You may have to, I don't know, go for a walk, come back, and then bam, you've got this property, which would be great. But it's all worth it at the end. It's a great tool to find edge cases and misconceptions about your code. So that's something where it really shines. And the most difficult thing would be coming up with properties, but you already know that you can have some inspiration for that. And you have to find the right balance. So each of the project is different. So I cannot tell you what percentage of property-based tests, for example, you would have to be safe. But if you find the sweet spot of having some example-based tests and some property-based tests in the right places, it will give you better certainty that your code is correct for the edge cases you know about and for those that you haven't even dreamt of. If you want to know more, you can take a look at those links. jQuick documentation is really great, and it describes more features of jQuick, which are great and useful. This is a great read. It's about Erlang, but it doesn't matter. The language doesn't matter here. Lots of examples of non-trivial, very smart properties. This one is this list of patterns that you can consult when you're coming up with your properties, and all the examples from these presentations are in the GitHub repo under this link. Thank you. If you have any questions, I would be happy to answer them. And under this QR code, if you have any comments or feedback to these presentations, I would be happy to take them under this link. Thanks.